started now.
Yeah, let's get started here.
All right, going live. And we're live. Hello, everyone, and welcome to the Gravity Max live stream. Today, we are going to be talking about Mars. So it's going to be fun. I am joined by my co-host, Sebastian. How are you
Oh,
today?
I'm doing well. I'm doing well. Very happy to be here to talk about Mars. As we've said before, it is the celebrity of the solar
Hmm.
system, most hit upon planet in science fiction. Maybe more than Earth itself, if you really think about it.
Hmm.
But I would say Earth is probably in the lead just because they typically
Yeah.
mention it, even if it doesn't take place on Earth. They're like, old Earth,
Oh,
and
yeah.
what
Yeah,
has
exactly.
happened to it.
Hmm.
But
And it depends on the sci-fi, too, like the
exactly,
genre,
yeah,
like their subgenre, I guess.
yeah.
But,
But Mars is certainly sci-fi's favorite planet, and I would say
hmm.
with good reason, very similar to Earth in terms of size. Venus is closer to it, but still same ballpark. And relatively recently, it was found that it actually has water on it in the form of ice, and we have sent numerous rovers over to that planet to take samples, take photos. You can check out all those
Hmm.
photos on like NASA's official sites, just anywhere else on the internet. I love the rovers. I love like the progression of rovers. In my mind, they all have different personalities. You know,
Yeah.
like Sojourner being the first super tiny, rover is the super like optimistic, like, yeah, let's go do this, guys. And then like Pathfinder is like has its own personality, opportunity, all that, um, and I love the Mars rovers, honestly. But more specifically, what we're talking about today is not the geography of Mars, because the geography, geo, is in reference to Earth.
Yeah.
We're talking about the areography, which is in reference to
Hmm.
Ares or Mars.
Yeah, exactly. Areography. Um, I don't know. It's more of a sci-fi term.
Mm-hmm.
Like people that study Mars don't actually use that term that much. They'll say like, "Oh, it's just the geology of
I
Mars,"
like
or
it.
the.
No, I like it.
But I'm like, no, areography is a good word.
Areography. You should do that
So
for all of the
yeah,
planets.
yeah, exactly. Lunography
Lunography. I love it.
and aphroditography.
Yeah.
They'll probably have to figure out something with that one. um, yeah. Anyway, so yeah, so we're going to talk about areography today. We can go through the planet like sort of like a tour of the planet Mars, like we would do a tour of Earth,
We're gonna look at
essentially.
some prime
Yeah.
real estate. Max is gonna tell us
Oh,
his plan
yeah.
for his summer vacation house on Mars. He's
Yeah,
picked out
exactly.
a fine location after Mars has been terraformed, and if you're watching this in the future, please come and visit him. We will go back to this
Yeah,
video and
exactly.
drop his address right here in
Oh
between
man,
in between my
we'll,
in between my hands.
we'll go back in time. The Mars address.
Yeah.
Yeah. Oh man. Um, yeah. Yeah. So we're gonna talk about Mars. All right. So first, the plugs. Visit Gravity Max website at gravitymaxmedia.com. Link in the description. Probably. Actually, that might not be in the description because it's like I don't know. Here, wait, I'll check. Okay, it's not in the description, so that's why just go
False
to
advertising.
gravitymaxmedia.com. It's that's just simple. It's our name, our brand name. But the other things are in the description. The social media, that's in the description.
Right.
So yeah. So go there. Instagram, Twitter, Facebook, Patreon. If you like social media. So also follow Sebastian on social media, Instagram and YouTube, 128 seconds. Links in the description. He makes videos that are 128
Yep.
seconds long, educational videos that are the shorter counterparts to these live streams for people that don't have 2.5 hours to like sit. So yeah, go check those out. And then my book, Somewhat Odd Start on Amazon. It's the third book in my first sci-fi trilogy. So yeah, and I think you'll like it. So go check it out. All right, Areography. So as we said, Aries, Areo is like the prefix for anything Martian. It's the adjective that's used in reference to Mars. Like while Areography might be it might not be like a bigwig sci-fi science term, right? Some terms that do actually use Aries in science are like areocentric orbits. So we've got geocentric orbits, which are just like commercial satellites use GPS. Then there's heliocentric orbits, which we have some space probes on heliocentric orbits, which just means going around the sun. All the planets are on heliocentric orbits. But then there are areocentric orbits, which are just orbits around Mars. Then there's also areostationary and areosynchronous orbits, which are the equivalent of geostationary and geosynchronous orbits on Earth, where a satellite will stay above one location on Mars. I'm not sure we actually have any satellites in that arrangement, though, at the time, in that specific orbital altitude. I'm not sure about that, because it could be useful for communications, but at the same time, I'm not sure. I think most of our satellites around Mars are actually closer to Mars. But yeah, so anyway, that's what we're going to talk about today. Areography.
Yeah. Mars, one of the frontiers. The red planet. And soon, Max's location for his summer home. What kind of amenities are you gonna need in that house?
Kind of amenities?
You going
for
here? Let me ask you this: you going for more of? So little spoiler. It's gonna be on a bay. So this is kind of like a beach house. Max is going all out. Is it gonna be more like a villa, or are you going more modern? Because we just had our architecture stream. Streams ago. What style are you going for?
I think it's gotta fit in with the terraformed but also Martian environment. I would imagine just uses of the warmer colors like reds and stuff. That would be the first thing.
Did we come up with a funny nickname for this one?
Well, we called it Areography, which isn't a real word, so
it's fair enough. But if we want to, it works. But if we want to change it, it could be Max's summer house. Oh
yeah, exactly.
Quick on-stream editing. You ready for this?
On-stream editing. Yeah, let's see. Are we ready?
Oh, I gotta do the back text too.
Oh yeah.
Home or house? I like house better.
Yeah. Yeah. Although you'd probably want to stay there year round.
This is true.
Just to be honest.
But all right, so what style are you going for?
Yeah, I don't know. I really can't say. Just coastal.
Coastal, I like it.
Yeah.
Get this thing just allow me to select it so I can move it down. Please. It's there's so many elements. Okay, there we go.
Yep. Yeah. It's tricky to change this. But yeah, I think another good location would be the Southern Highlands for some mountain hiking and stuff like that.
That you definitely want a more whenever there's a mountain house, I like when it's built into the mountain.
Oh yeah. Yeah, there's some good crater rims down there where you could build your house into the side of a crater, which is just interesting because you could make it invisible from orbit, have it in the side of a cliff. That's an interesting look. And then of course you have all the mountain climbing that you can do down there. I don't think you'd really want to go for one of the shield volcanoes because that would be a bit too much elevation. But let's just get right into it.
Yeah.
So the first and most important and most striking thing about Martian geography that a person should notice is something called the Martian dichotomy. So if you look at a map of Mars, or if you look at a picture of the planet just normally, like as it is, it'll just look like a red mass of like, oh, some parts are darker red and some parts are lighter red, and there's not really much noticeable difference there. Whereas, with Earth, you can plainly see blue or green. If it's blue, then it's ocean, and if it's green, then it's land. And you can see like the mountainous regions will be whiter, with peaks and stuff like that. But on Mars, you don't really get that. You can't really see that right now. So it's useful to look at Mars through a topographical perspective. So that is an elevation map where elevations correspond to colors on the map. And when you do that, you can very clearly see that the northern hemisphere of Mars is about, well, it's a few kilometers in elevation less than the southern hemisphere. The entire northern hemisphere has a lower elevation than the southern hemisphere, which, like, on average, which may seem weird. Like, how can one entire half of the planet have a lower elevation than the other half? Because, like, if you think about, like, a sphere, you just think, okay, so the sphere is just centered here. But it just is. It just is. I mean, if you think of Earth, I would say Earth's southern hemisphere is probably on average of lower elevation than the northern hemisphere. And that is because, like, there's twice as much land in the northern hemisphere as the southern hemisphere. So the southern hemisphere is mostly ocean. And so if you stripped away all of the ocean, then you would see that the southern hemisphere is a lot lower in elevation than the northern hemisphere. But yeah, so that's basically Mars. Mars, without an ocean, you kind of have to just look at an elevation map because there's not much to see. So yeah, so let's pull up that elevation map of the two hemispheres.
Yeah. Just
so,
it up.
All right, yeah. So as you can see very clearly, northern hemisphere is lower than the southern hemisphere, just on this color thing. But then other prominent features that you might notice to the left here in the middle, like around the equator, is what's known as the Tharsis region, which are those tall mountains, including Olympus Mons, the tallest mountain in the solar system. Also, right next to Tharsis, you have the Valles Marineris, which is one of the features that is very prominent from space. That is probably one of the most distinctive features of Mars from space, is the Valles Marineris, because it can actually be seen without the use of an elevation map. Then in the southern hemisphere, like to the southeast a little bit, you've got that crater Argyre in green. That's a fairly big crater, but of course it doesn't compare to the one farther east of it, which is the Hellas crater. So the Hellas crater is the largest, disputably the largest impact crater on Mars. It could be the second largest because some people say that the entire northern hemisphere is an impact crater. Just the whole hemisphere is an impact crater. And we'll go over that in a second. And then northeast, you've got the other major shield volcano mountain, which is Elysium, the Olympus Mons. So that's sort of an overview, and we'll get into the specifics a bit more in just a bit. But yeah, then there's also polar caps made of water and carbon dioxide ice. So we'll get to all that and more later in this episode.
Yeah, I love just the fact, because we're so used to seeing just the Earth map, and it's awesome to think that one day we might be looking at, like, we probably wouldn't be looking at a topographical map, but we'd be looking at a map, similar to this, with like capitals of the different provinces everywhere. And like all of the stuff, and like a political map of Mars. That's awesome, with borders of countries and stuff. and all that kind of stuff. It's just,
Yeah, exactly.
I don't know. It's the
It would
sci-fi
be cool.
nerd in me that's like, oh, one day to be able to see all of that, and to be able to just sit
Yep.
here right now and like hypothesize what would humans do if we colonize Mars. Because I mean, I'd like to think I know humans pretty well, having been
Hmm.
around them for quite some time.
Having been one
Having been
for a
one
little while.
for a decent amount of time. But I mean, right now we could just throw out like predictions of what would happen. You know, some guy would try to climb Olympus Mons. Eventually, someone would do it. You'd probably have to build like a custom suit because of how
Yeah.
high it is. But some guy will sail the northern ocean if we
Yeah,
were to terraform
once
it.
it's constructed.
Yeah.
Yeah, we'll get to that. I think we can talk about all those predictions on like we have like slides for all the different geographical features. So we'll get to that in a second.
Yeah.
But yeah, one last important thing about the two hemispheres is, and just the concept of elevation on Mars is, how do you measure elevation on Mars? Because on Earth, it's pretty simple. We say sea level, right? There's this massive contiguous body of water that spans the entire globe at a certain elevation. And so that is the natural 0 point. But how do you just set a 0 point on Mars? It would seem kind of arbitrary. So the way that scientists have done that, they've defined sea level at what they call the datum. So the datum is the elevation at which the average air pressure is equal to the pressure at the triple point of water. So that is about 610.5 pascals of pressure, which is about 0.6% of Earth's atmospheric pressure at sea level. And so that's a lot of words right there. But what that means is that when you have an air pressure below 0.6% of Earth's standard, water in its liquid form is physically impossible. So if you've ever seen videos of dry ice where the ice turns directly into carbon dioxide gas, that is how water would behave too. So with air pressures lower than 0.6%, the water will either be ice or vapor, nothing in between. With air pressures above 0.6%, you can actually get liquid water, assuming you get to the right temperature, which Mars rarely does, because Mars is also too cold. So low pressure and too cold. But basically what this means, right, is that since lower elevations have higher air pressures and higher elevations have lower air pressures, on Mars, anywhere below the datum could theoretically support liquid water, were the temperature correct, right? So it has the right air pressure to support liquid water. Anywhere above the datum is incapable of supporting liquid water. So there cannot be liquid water above that altitude, which is the 0 altitude for Mars. Yeah. And so on this elevation map, that roughly corresponds to the green zones. The green zones are about where the datum is. So that's your rough guide. But of course, with if humans go to Mars, almost immediately they'll start affecting the environment of Mars. And so probably intentionally, but also unintentionally, definitely. And what that would likely do is increase the air pressure. So humans would want to increase the air pressure on Mars just because that makes it more livable for humans. So that would basically, the datum isn't going to change because that's just the 0 elevation mark. They're not going to change how they measure elevations. But what will happen is slowly the triple point of water will rise in altitude. Like the definition of the datum will rise in altitude, even though it won't. Like, that's complicated, but I think you get what I'm trying to say. So as the atmosphere gets thicker, then Mars will be able to support liquid water at higher and higher elevations until eventually it can support liquid water at all elevations. And so then the datum will sort of become arbitrary again. So yeah, that's what it is. But that's the elevation metric, and I think it does a good job because it's roughly in the middle. You know, if Mars had oceans, they could conceivably be around that elevation, probably a bit lower, but around there. So, yeah. But yeah, so let's get to the theories on why Mars has this Martian dichotomy. So, theory one is an impact or multiple impacts. So, the early solar system was very chaotic and violent, and so that has manifested. I mean, that's why the moon exists. It's theorized that the moon was created by a massive object impacting the Earth about the size of Mars, actually, another planet essentially, just crashing into Earth. And so this hemisphere dichotomy might be the result of a similar impact. However, if you look at the shape of the of the basin that would have to have been, it's stretched out on the Mercator projection we essentially have here. But if you were to look at the pole, it's kind of like elliptical. And so that might suggest either that there were multiple impacts all around the same place, like some object broke up before hitting Mars, or that maybe it hit Mars at an angle. The question there, I guess, would be, why didn't it create a major moon? Which is just something interesting to think about, because Mars does not have any major moons. It just has minor moons, asteroids. So, yeah. But that's one theory. The other theory is called the Endogenic Theory, and this is basically just early plate tectonics just sort of did this. Those are the two theories for Mars. It's that this is just a coincidence of plate tectonics, which have mostly just petered out on Mars just as it's cooled down. So, yeah, those are.
Which one do you subscribe to, Max? Which theory?
So I think the impact one is just more like poetic. I don't know. Mm-hmm. So more like mythological almost. So I haven't really done a review of the evidence enough to really make a logical conclusion about that. But I would say the impact one is just sort of interesting.
Yeah.
And I like it. That's all. I like it because it sort of gives Mars an interesting common feature with Earth, because Earth had that massive impact too, probably, that created the moon. Mm-hmm. And so that's just sort of an interesting thought. Also, it's just like interesting when you look at the surface of Mars, especially in the southern hemisphere. The southern hemisphere, you might have noticed, is incredibly cratered. Even ignoring the large craters, there's so many small craters just all around the southern hemisphere. The northern hemisphere, not so much. The northern hemisphere is younger, but it's just interesting to think about because this is what Earth would have been without like weathering and erosion. You know, I mean, think about that massive impact on Earth that created the moon has been completely just dissipated. You know, like there's no physical crater or evidence because that crater would be the size of a hemisphere, you know, and we haven't seen that on Earth just because the plate tectonics after 4 billion years have destroyed the evidence. And so that's a very interesting thing about Mars is that it has not had as much like erosion, weathering, and just like plate tectonics. So its surface gives more insight about the early solar system. But honestly, it's its surface more is like gives it insight about itself, because Mars may have had water at one point. We don't know, but if you look at the northern hemisphere and how it's so much younger, it kind of seems like there might have been an ocean there at one point. And there's probably a lot of permafrost underneath the surface too in the northern hemisphere, as well as some in the southern hemisphere. But it's just interesting to think about. And yeah.
Yeah. It's, that stuff is always really tough, and I wouldn't be surprised if we actually got an answer to which of the two theories is more likely to be true, because again, all of this stuff happened so long ago that it's a little difficult to figure out which one it might have been. But again, we've sent, was it 5 rovers in total, maybe 6 if I can count, but taking samples, doing research, sending back data back to us here on Earth. And when we eventually get people there, then we can just start doing data and research there, which helps us out exponentially.
Yeah. And something interesting is, on Earth, we've been able to puzzle out historical impact craters, just where the crater might not exist anymore, just based on rock layers. So you'll be able to see in the Earth's, like, if you just dig straight down through the Earth's rock layers, you'll find like a thin line where the asteroid impact that caused the dinosaurs' extinction is, like, the evidence of it is. And the evidence just comes from like, all of these rocks have a similar composition. And that's just due to the, like, impact causing, like, debris to spread around the globe. And that is just sort of interesting as evidence. And we haven't really been able to look at that on Mars. We haven't been able to do very extensive, like, geological digs on Mars, because the rovers are only able to do so much. Like, I think, like, we have, like, the Perseverance rover, like, recently tried to do its, like, little sample dig, which was, I think, like, not more than a meter, maybe a foot into the ground. And when it tried to pick up the sample, like, it was actually regolith instead of rock, so it just crumbled. And so it didn't get any, like, it didn't get a sample. It didn't get any useful data from that, which is, like, unfortunate. So it's really going to take people to actually get to Mars, whether on, like, temporary Mars missions or just permanent settlement. It's going to require people to actually go there to get a lot more information about Mars's history and then the solar system's history as a whole.
Yeah, absolutely.
All right, but yeah, so let's do our region tour of Mars. We start with the northern lowlands. So the northern lowlands are where there historically may have been an ocean, and the surface is much younger and much less cratered. So yeah, lower elevation, just, like, interesting place. Probably, I think it's a good site for an initial like, Mars base, an initial Mars settlement. I think, like, maybe something like Chris Planitia or Isidis Planitia might actually be good spots for an early Mars base, because they are likely to have some permafrost, some water in their surface, but they're still close enough to the equator that you get a good amount of solar power, which is likely what an operation like this would use to run off of, supplemented by some nuclear power, I would guess, but that's not as important as on, like, the moon, where the sun doesn't shine for 2 weeks straight. But yeah, so that's, and there's actually been, like, some interesting things in the north. So let's start with Vastitas Borealis. So Vastitas Borealis is this ring around the North Pole. And we'll talk about the poles at the end. So this is a picture from the Phoenix lander, the Phoenix Mars lander, and there's a map showing its location. This is just an interesting place. This picture is pretty interesting. You can see that this surface is mostly just dust, and there's not as many rocks here. It's just fascinating because the southern hemisphere is much more cratered than this. But yeah, it's just cool to see that picture. Yeah, I don't know. There's not much to say here. There might be permafrost underground. There probably is. It's hard to tell, but that's what it looks like.
For terraformation, because this is in the northern hemisphere, would this be completely submerged?
Oh yeah, Vastitas Borealis would be completely underwater if you wanted to have like a meaningful amount of water on the surface of Mars, which is like it's an interesting question of how much water you can have on the surface of Mars just based on local sources, and how much you might be able to like import water, which would be quite like impractical, and it just depends on how much energy you're willing to spend on that. But yeah, this part would be the first to go underwater, because this part of the planet, well, it's not the lowest elevation, because the lowest elevation would be found in Hellas, the Hellas crater. But up here is just, and if this is not indeed a crater in itself, right? If this is like endogenic, then this would be the deepest, naturally occurring part. I mean, I guess craters are also naturally occurring, but I don't know. Intrinsically to the planet, this would be the deepest part rather than an impact, but jury's still out on that. But this is probably where the global, like the Northern Ocean would start, if there is to be a Northern Ocean, because there's likely permafrost here. This book, and I'm reading Red Mars while I'm rereading it, they set up huge factories in Vastitas Borealis above permafrost and aquifers, and these factories just dredge up water and then just like spill it out onto the surface and create giant ice sheets that eventually like span the entire ring around the northern hemisphere and then slowly melt into an actual ocean. So that's sort of, it's interesting. I mean, what we're looking at here could be a dried up ocean bed, like just from this picture. It's like hard to imagine, but at one point Mars probably did have water on its surface, and this is where it would have been. So this is like we're looking at the bottom of the ocean, and that's just interesting. You can also see that it's very flat. There's not many mountains around, and that is pretty distinctive of this area too, because the rest of Mars has a lot of elevation changes up and down very quickly. So
yeah, I think that's about it. We were currently looking at the bottom of what will hopefully be an ocean.
Yeah, that would be pretty cool. I imagine someone might put like a buoy right here in the future, right?
Yeah.
So say there's like an ocean, someone would put a buoy and call it like the Phoenix buoy, just to be like, oh, the Phoenix lander was once here, although now it's not, because we put a giant ocean here. And so
yeah, I could
we
totally
hauled the
see
Phoenix
that
lander
happening.
like to a museum somewhere else. Like that's an interesting thing to think about, is that once people go to Mars or the moon, it's like, what will end up in museums that we've already put there? Just because, like, not like, if you think about it, like naturally, right? Say there's a few thousand people on Mars, someone's gonna think, hey, you know what? I should go just like find the Curiosity rover and like keep it I should just bring it home, you know. Um, so
Yeah.
it's like it's just interesting. Like if you were on a moon base, you would want to see the Apollo 11 lander, of course. You know, even if it's like an initial moon base, and you know, there's only a few thousand people living on the moon, you would want to like take the rover out, and you would probably, or the moon buggy, you would probably find any justification you can, like, oh, there's an interesting geological feature that I want to investigate further that just happens to be near the Apollo 11 lander, you know, or any of the Apollo era landers, and just be like, yeah, I'm going to go there. And people will be like, oh, really? Is there a lot of science to be done there? You're going to be like, yeah, totally. You know, like to justify the trip. So yeah, so that's interesting.
Yeah.
But yeah, next we have some northern Planitia, which means plains. Basically, all the words for geological features on Mars are basically the same as they would be on Earth, except slightly different. So plains are Planitia or Plana, like a planum. Multiple would be Plana, I think. That's just my guess. Mountains are Montes or Mons. You've got Terra, Vallis, you know, all these features where you can kind of guess what they mean just based on what they sound like. But here we have a map of some of the Planetias. We've got Arcadia, Acidalia, Amazonas, Chris, Isidis, and Utopia. So this picture here is from the Viking 2 lander, which also is on the surface of Mars. And so that picture is of permafrost, or not permafrost. That's just morning frost. That's like on the surface, like on a cold day, you can see just frost, water just forming on the surface. So this is just pretty interesting. Because that says that there's water vapor in the atmosphere of Mars, you know? And that's just like a very earthly experience to wake up on a cold day and find that like your car has frosted over. Like that, you know, the planet Mars is a lot more like habitable than we might think, I feel. Like people always make such a big deal about water on Mars, but like we've known there's water on Mars for a long time. If you just look at the polar caps, those have been visible from space. The question is about liquid water. That's probably a lot more rare. But here, plenty of water, just not in the correct form on the surface of Mars. So that's interesting. And you can see that this part's a lot more rocky. So you're getting out of that smooth vastitas ocean bed. And it's just interesting to look at these frost-covered rocks.
Yeah. The terrain on Mars is really fascinating to me. Just to see it, like, even just like to think about the fact that such a small percentage of humans who have ever lived get to see these photos. Like, I was super jazzed when we got the first photo of a black hole.
Oh yeah,
I remember that. I love that. You know, just to be able to, because I mean, it's not like we didn't believe in Mars or we didn't like believe in black holes to some degree. It's just seeing it just allows you to experience it in a completely different way. You know, like theoretical versus experimental. This is like experimentally, you know, I guess experiencing whatever scientific subject you might be looking at. And because when you look at photos like these, you can just imagine yourself walking around, you know.
Yeah, exactly.
Like, we're taller.
Walking around Utopia Planitia.
Yeah, exactly. We're just, you know, we're taller than most rovers. I don't know really how high they extend, but
actually the rovers are like surprisingly larger than like
I know they're larger than we would expect. I don't know about tall though. Like, I mean,
maybe
straight vertical.
Yeah.
But in any case, you look at a picture like that, you can imagine yourself just, walking around. And obviously you wouldn't be able to just like walk around because there's no like oxygen, but or very little. But once humans can imagine themselves doing something, they will be that much more likely to do it, and it becomes that much easier for you to do it because, think about it in any sport. If you have a coach and he or she's telling you what to do, probably one of the first things they'll say is visualize what you want to do. You got to visualize yourself hitting the target or, getting across the field or doing whatever. With photos like these, we're able to visualize it, and I think that's pretty powerful.
Yeah, definitely. And like the frost is like strangely like deceiving because it almost feels like, oh, it's just a cold day. Like, and even the sky here just looks like an overcast, like cold. This is just, November in Connecticut, pretty much.
Yeah.
Like this is what it looks like. There's just random rocks everywhere. And there's frost on the ground, like half a centimeter of snow. That's what it makes me think of. So it's almost like you could just walk around in like a sweater, but then you're like, no, that is deadly Mars. There's not any oxygen there for you to breathe. But it's like strangely inviting, a lot more than you would think for just another planet. Because when you look at pictures of the moon, they definitely do not have that same feeling. You can tell immediately that place is dead. Like there's nothing, there. It's inert. But here, Mars is already a lot more lively, than the rest of space.
Yeah.
All right. So next up, we get into the Tharsis Province.
Badass name.
So this is, Tharsis. This is a huge region on Mars that consists of basically a chain of shield volcanoes, and it is like an entire elevated, like, continent. It's like a giant Hawaii, basically. That is Tharsis, because these are not the result of fault lines. Lots of volcanoes are fault line volcanoes. Like if you think Mount Fiji, right? That's the result of two tectonic plates crashing into each other, and welling up like this. But here on Mars, this is just hotspot volcanoes, sort of like Mauna Kea in Hawaii. Right, that's the one in Hawaii. I'm not sure. It sounds like it would be in Hawaii.
Yeah, I'm sure it is.
But that is just the underground hotspots that are welling up to form these volcanoes. And so there are a lot of volcanoes here. They're all dormant. There's no lava coming out of them today. And there's 4 of them that are the most prominent, but there are a few more just dotted around. So, let's begin with the central 3 here, the main 3, Tharsis Mountains. We've got Arsia Mons, Pavonis Mons, and Ascrius Mons. So this is just sort of interesting. You can see off to this picture is sideways, so east is downward. All right. You can see off to the east these just cracks and fissures in the ground, and that is from the sheer bulk of these volcanoes alone. These volcanoes are so massive that they've formed massive fissures around them. The most massive, of course, being Valles Marineris, and we'll get into that in a bit. But something else interesting in this picture you can see is that Pavonis Mons, the peak of Pavonis Mons, roughly lines up with Mars's equator, and that means that it would be a prime location to put a space elevator. So that's something interesting to think about. And in the book I'm reading, they do that. So because naturally, like, it just makes sense to put it there. It's like, because these mountains are like ramps up into space, because they go much higher than the mountains we are familiar with on Earth. Uh, Mount Everest goes, what's the elevation? It's like, wait, I'll look it up. I think it's 8 kilometers, right? Mount Everest is like 8 kilometers of elevation. So these mountains are the largest one, Olympus Mons, is 21 kilometers above the Martian datum.
Yeah, Mount
And
Everest is
these
8.8 kilometers.
8.8 kilometers. So these mountains too, they're not as tall as Olympus Mons, but they're, a few kilometers less. And so these mountains just casually double the height of Mount Everest. And that is just crazy. So these mountains are like little platforms into space. And it's just kind of strange to think about, because even if Mars had an atmosphere at the datum that was like similar to Earth's, these mountains would have very low air pressures regardless. So from the highest point on Earth to sea level, Mount Everest has about a third of the air pressure that's we have at sea level. And so if you look at the highest point compared to the lowest point on Mars, that would be a factor of 10. So compared to the low point in the Hellas Basin, Olympus Mons, which we'll get to in a bit, and these mountains too, have an air pressure that is 1/10 as much. And that stays even if you increase the air pressure at the lowest point to earthly air pressures. So if you have earthly air pressures at the lowest point, then Olympus Mons and the Tharsis Mountains will only have 10% air pressure, which is practically space. So it's just pretty interesting that these mountains just sit above the atmosphere almost. So, yeah. And then something else interesting is that they're also just very broad, like wide-based mountains. So climbing them wouldn't feel like that much of a climb, except in the parts where there are cliffs occasionally. But these are just like giant on-ramps, essentially. Like, they're just cones, and they're very, like, they don't have very steep slopes. So it's sort of interesting about how it would feel to climb them, especially these Tharsis Mountains. Would probably be kind of boring for your average mountain climber. But probably the best mountain climbing places in the Tharsis Mountains would be on the inside of the calderas at the peaks of the mountains. So the old calderas where lava used to come out that have since dried up, if you were to climb the rims of those calderas, that would probably be like good views. That would give you some good rock climbing experience. But I think Olympus Mons probably has the best rock climbing location on Mars. So let's go to that. So Olympus Mons,
the famous
mountain.
Yeah.
Yeah, Olympus Mons needs some like good heavy drums to cue it in. Whenever you say Olympus Mons, you need like boom, 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 boom. You like that's how everyone thinks of Olympus Mons. And so Olympus Mons is incredibly tall. It is 22 kilometers above the datum, and so it is just a behemoth. It is as wide as France. So if you overlay Olympus Mons above France, Olympus Mons basically has the same area as the country of France, just a little less, which is just crazy. And so something interesting about Olympus Mons in terms of geology is that it is actually the youngest volcano of this system. So the Tharsis Mountains are older. And this is interesting. So Olympus Mons, it's the tallest mountain on Mars and the tallest in the solar system. And so it might be weird that it's the youngest. You might think that it's weird. But when we look at the tallest mountains on Earth, the Himalayas, they also happen to be the youngest mountains on Earth. Did you know that? The Himalayas are the youngest mountains on Earth,
Hmm.
in that they're still actually sort of forming. They're still just the Indian plate ramming up against the Asian plate, those two continental tectonic plates crushing together and creating the Himalayas. So the reason that the tallest mountains will tend to be the youngest is that since they're the youngest, erosion has had the least amount of time to work on them. And so on Earth,
Oh,
yeah,
I got you.
right? Right? It's interesting.
It's
On
all
Earth,
coming together.
yeah, the erosion occurs much quicker on Earth than on Mars. And that's part of why mountains can't get as tall. It's also that gravity is is much greater on Earth, and that like eventually if you had a mountain like Olympus Mons on Earth, the crust that it sits on would just start to sink into the mantle, like, which is just crazy. And that is actually sort of what happens to these shield volcanoes. So Mars doesn't have water to cause erosion, and it doesn't have very great wind erosion. The wind erosion would take much longer than it does on Earth. But what Mars does still have is gravity, and that is the primary way that mountains erode on Mars, which is just crazy because that also takes a long time. So basically what happens are these mountains just slowly like sag and deform into the earth over, you know, geologic timescales. And that is what has happened to the Tharsis Mountains just a little bit. The Tharsis Mountains are still very tall. But that's what happened to Alba Mons, which we'll talk about in just a moment. And that is eventually what will happen to Olympus Mons. And that is why you get these huge fissure systems too, because you have this huge mountain and then it starts to just like press outward on the area around it and create these fissures. And then, yeah, let's see. So then it's like you get these like outflows of just collapsed, lava rock, and it's pretty interesting. So now we get to the best rock climbing location on Mars, and that is this escarpment that goes around Olympus Mons. It's a giant cliff, basically. So Olympus Mons has huge cliffs around its edges due to those parts of the volcano physically just collapsing under their own weight. So, these are just collapsed rock leaves the mountain sort of sheer with these cliffs. And those cliffs can be many kilometers high. And so those would probably be the most thrilling rock climbing locations. But something interesting is that it's also would probably be the best view. If you were to go to the peak of Olympus Mons, the very top, you would not be able to get a good view of the surface of Mars. You would just be able to get a good view of the rest of Olympus Mons. Because again, Olympus Mons is so big that if you were to stand at the top of it, you would see nothing but more Olympus Mons, right? So if you want to get a good view, you might actually get it on the edges of those huge cliffs looking out over the plains below. So that is your travel guide for Olympus Mons. Very interesting place. But otherwise, it has an average slope of 6% grade. So that's like 6% grade is quite low. Like, I think highway, like, federal regulations allow up to like 8% grade or something before you have to start like taking some like extra measures. I'm not sure about, I don't know all about that, but I know that I've been on roads that have 6% grade, and it's like, I don't think they even put signs up until it's 7% grade. So it's like, this is not a very steep mountain, excepting the great cliffs around it. So, yeah.
Yeah. The most menacing mountain that we have at our disposal.
Yeah, exactly.
Size of France, much more palatable. It is a tourist destination.
Oh yeah.
To say the least.
Yeah, it's just like It's just fascinating. It would be cool to go in up to the peak and then just travel around that caldera too, to just look around. And it is interesting, like when you think of the gear that you would need on Mars, right? So in space, and when we have the moon missions, you have those full bulky spacesuits that we think of when we think spacesuit. But theoretically, on the ground in some of the lower lying regions of Mars, you wouldn't need a spacesuit that's that bulky, right? Like you could get sort of a different design. In the book I'm reading, they call them walkers, and they're basically like elastic. And so instead of, and this is like, I think flight suits are made like this. So instead of basically what a spacesuit does, like that you would see on the ISS or on the moon, is it just creates a small like bubble of air for you that is at the appropriate air pressure. But what a walker or like a flight suit does is it just is made of like elastic material, and it squeezes in your skin to just prevent you from like ballooning outward. So it doesn't actually provide you with air pressure, right? It's just like a large elastic thing that like squeezes on you to allow you to be able to breathe in, which is like strange because you'd think if something's squeezing on you, it would be harder to be able to breathe. But the way that it works is, well, it actually sort of does make it harder for you to inhale, but that's the point, because it's like, well, it's hard to explain, but it's like, otherwise, the pressure, it's like outward pressure, because we are naturally acclimated to one atmosphere of pressure. And so if you're in a low pressure environment, you need to have that elastic force squeezing inward to counteract the outward force of the pressure. And so if you have one of those walk suits and then just like clip on a helmet, that is the setup that they have in that book that I'm reading, Red Mars. And so that thing that you could do at the lower elevations, you probably couldn't do at the higher elevations, because the higher elevations are much more like space. So, yeah.
Yeah. So we can pop
All right,
on
next
over
up,
to the next one. Yeah.
we've got Mons. So Mons, kind of a footnote here. This is what happens when one of these shield volcanoes ages. So this older mountain has just sunk into the ground because of gravity and time. At one point, it probably was as large as Olympus Mons. So if you look at this thing, you can see there's a ton of these cracks around it. And those cracks are just from the rock sagging and pushing outward. Like, you could do this probably with like some material. I'm trying to think of like what material you could look at to like see something interesting like this. I don't know, if you have like a stretchy material, right? And then you like stretch out the top a bit too much and then like press it down again, you'll see these like folds, The surfaces of planets are like surprisingly elastic just over long periods of time and long distances. Like if you look at how the Earth's crust behaves on like a macro scale, it's almost like, why does the Earth's crust act like Play-Doh? It's just like, it's strange like that. But that is almost what you can see here. I mean, look at those fissures so clearly going around Mons. Like, that is just crazy to look at, because these fissures are like giant canyons if you were to get down into them, and they just go for thousands of kilometers, it looks like, and they just bend and warp around this mountain. Mm-hmm. So very interesting feature. This is basically over time what would happen to the Tharsis Mountains and Olympus Mons if you were to observe them over millions and millions of years. So, yeah. All right, so next up, we have these northern Terra. So this is Tempe Terra, Xanthiterra margaritiferterra, and you've got Lunae planum. So the lone planum here, too. And this is just an interesting region for a few reasons. So you have these outflow channels. On the right, we have a zoomed in look at Margaritifer, and here, these outflow channels are pretty interesting. There's Shalbatana Vallis, there's Ares Vallis, and in the middle you've got Tew Vallis and Simud Vallis somewhere in here. And so these are long flowing valleys, and they almost look like rivers. Like, they really do. Look at Ares Vallis off to the right here. That, I mean, this just looks like a river delta. Like, that's what it looks like to me, right? And so these are probably, they're called outflow channels because they are probably dried up riverbeds. So formerly, this is probably where water flowed on Mars. So water just flowed down through these channels to get into the ocean, which is just fascinating to look at. But they could also be cracking features caused by the Tharsis bulge. That is, the Vallis marinaris is caused by that. But if you look at the shapes here more specifically, these don't just seem like, cracking features. These look more... Well, another possibility is that these could be cracks that opened up because of the Tharsis bulge and then were widened by erosion. And the question would be, what kind of erosion? Either water or wind erosion. So I would say it's probably water erosion, just because it looks a lot like that. But it could also be wind erosion over time. So, because I think these areas are actually fairly windy, just because they're like channeling the wind. Sort of like how in a city, you'll get those big winds going through when there's like the grid patterns on the cities. Have you ever heard of that, where there are huge gusts of winds just going through these like valleys, essentially, these artificial concrete valleys? So yeah, that's this region. This is like a formerly coastal region, if you can imagine. Imagine these rivers flowing off of these mountain ranges, right? So these mountains, collecting snow and glaciers up at these high elevations that then flow down through these valley systems and into the large ocean. So that is what I think of here.
Yeah, absolutely. Like, when you look at that, you can just imagine, like, different islands, bridges going between them. Like, I was just in New York, actually, a couple of hours ago, and I was near the lower left half, or not half, like the lower left part of Manhattan, to check out the Van Gogh exhibit, actually, and it was like right on the water, and we grabbed lunch there, and the breeze that came off of the water through the buildings into the place where we eat lunch was really, really nice. And I could see, like a system kind of like New York City setting up around here with, like, obviously not covering all of these islands, but having different bridges or other means of transport around here. Again, it's just me being very sci-fi. Oh, what would this look like if humans got there?
Yeah.
Yeah,
exactly.
I'm sure we'd figure something cool out.
It also really helps with the coloring here, that the elevation coloring is green and blue.
Right.
Like, it really makes it easier to imagine these like green land areas and then blue ocean areas. Yeah, like this would totally be like a little coastal like archipelago. Yeah, that's just interesting. Like, if you look at islands within rivers, these are what islands within rivers look like. But yeah.
Pop over to the next one. Or the next...
So here we've got... Oh, yeah. Next slide.
Oh, yeah.
Here
sorry,
we've
I
got...
thought we were at the end of the section.
Oh, yeah.
No, we are not.
Oh, yeah. We've got two more quick things
Yeah.
here. One is Valles Marineris.
The
Look at this
famous Valles Marineris.
Yeah. Valles Marineris, also, I would say, one of the best rock climbing areas on
100%.
Mars. Yeah, look at this thing. This thing is just incredible. So, this is a whole system of valleys and cracks that formed because of the bulk of the Tharsis Province. And there are a few different chasms here. So, you've got Ias Chasma off to the left. That's that big arm to the left. Then you've got, let's see, you've got Meles Chasma in the middle. So this, like, where it widens out in the middle. Then you have Candor Chasma, which is the section that extends to the north. And then finally you've got, what's the last one? The last one is Coprates Chasma, off to the right, off to the east. Those are the four main chasms here. There's also two more of note. I would say just one more. I would say like Ophir Chasma, which is just even farther north than Candor. And then Hebe's Chasma is kind of interesting just in terms of like potential observations of water, possibly liquid water within Hebe's Chasma. And so that is just an interesting place. But yeah, this whole feature is very fascinating and very visible from space. That is like probably one of the most recognizable distinct features of Mars from space, just that it has that huge like gash going across its face right there. So yeah, and these were probably also filled with water at some point too. So that's just interesting. I mean, if we think of how the canyons on Earth formed, like Grand Canyon is just the Colorado River wearing it down over long periods of time.
Yeah, and it's one of the
But
most...
this is a... Oh yeah, sorry, go ahead.
It's one of the most distinctive features of Mars, like the scars along its side. It's just... I don't know.
Yeah.
I would love to stand near it. Be like, I want to go to the Grand Canyon as well.
Yep.
But Valles Marineris right up there with it.
Stand at the bottom of Valles Marineris. Something interesting is that, so this valley is so much larger than anything on Earth. Like the Grand Canyon, so much taller and so much wider, right? Like this would be like a valley that spans the entire continent of North America and goes a few kilometers deep. But apparently, in the widest sections, if you were to stand in the middle, the like walls, the canyon walls would be so far away that they would actually be over the horizon and you wouldn't see them. So you wouldn't be able to tell that you're at the bottom of this massive canyon system. Only when you're near one side or the other can you actually tell that you are within Valles Marineris, which is just kind of fascinating as well. Yeah, that would be a good city location, I think, at the top, overlooking one of these valleys, Like, I think Coprates has some pretty clean cliffside. So imagine having, like, a town that is just right on top there, and you just look off. You look down at that edge. Oh, and imagine hang gliding.
That would be insane.
Yeah, that would be good.
Or imagine you had like a squirrel suit or something like that.
Oh yeah.
That'd be crazy.
Yeah, exactly.
I bet someone would do that. Like I'm just thinking about all the different feats that humans would try and accomplish.
Yep.
Someone hang gliding all the way across, even though that's insane. But going all the way across, just doing it. How long is it?
Let's see. I'll have to look that up.
Jamie, pull that up.
Jamie. It is it's a significant fraction of the planet, it seems. Okay, let's see. Valles Marineris, or Mariner Valley, is a vast canyon system that runs along the Martian equator just east of the Tharsis region. Valles Marineris is 4,000 kilometers or
Oh my
2,500 miles
god.
long
So I
and
think that's
reaches
pretty
depth of up to
impossible.
7 kilometers. Oh, well, that's not about the thickness. Oh, yeah, to go from to
From
go the
like
long way, but
to
maybe
go
to
the
get
long way.
from one wall to the other
Yeah.
might be more feasible. But yeah, so 7 kilometers or 4 miles deep. And for comparison, the Grand Canyon of Arizona is about 500 miles long and 1 mile deep. So take that, Grand Canyon. Yeah, Mars is just interestingly littered with oversized geological features. Like geological features that are present on Earth, scaled up by a factor of 100, are like all over this planet. That's what you'll see. Just giant geological features on a small planet, which is just interesting.
All right.
Then finally here we have some southern plana. So plural of planum, I don't know, that's my guess. So we've got Daedalus, we've got Syria, Sinai, Thaumasia, and Solus. And these are just plains of igneous rock that, lava that has flowed out from the massive volcanoes up above. And these are still, these are like mesas, these are highly elevated plateaus. So these regions would not, again, the whole Tharsis province is like the last area that would become habitable, right? If there's going to be a terraforming effort, this would be the hardest area to make habitable, other than inside the valley, just because of the elevation. Being higher in elevation just kind of makes everything a lot harder, just because there's not as much oxygen. So that's about it. I mean, it's a simple principle, right? It's interesting if you go up the mountains in any particular area. If you go up high enough, you'll notice that the trees will just stop at a certain elevation, right? So you'll see like dark green, then just like lighter green of like grass. And it'll be like if you were to get up to that elevation and look out, you would just see a straight line. Like it is a very strange, unnatural looking thing. But the trees they almost just know. Like it's like at a certain altitude, they just all stop. They just all cut out all at the same time, just because it's too high up for them. They're not going to thrive. They're not going to survive as trees. So they just don't grow there. And that is just interesting to look at. So, yeah.
Yeah. Just, I want to be there. I want to go to space, Max. I want to go to Mars.
I just want to walk around. I would just walk around. Walk around 100%. Mars for like days and days at a time. In the Red Mars series, in the third one, Blue Mars, where Mars is like pretty much fully terraformed, they have this annual, and these are Martian years, annual race called the equatorial race, where you just run around the planet once in a loop. It's like that's the race. So it takes you many months, obviously, and it's like hiking the Appalachians or something. And so it's like you have your little pack of like food and stuff, and you restock along the way. And so there's this chapter that just describes someone doing this Martian circumnavigation race, which is just fascinating to think about, because it's a smaller planet, but it's still a planet, But yeah, that would be fun to do, to just go around Mars, just go around the whole thing, just looking at it.
Yeah.
But yeah. Next up, we've got the Elysium province, which
Badass
is the second.
name.
Yeah, Elysium. What is that? That's Greek mythology, right? That's like
Yeah,
the
I think you're right. Let me check.
that's like,
Gardens or
or it
something?
might be, yeah. It's like, I know it's some mythology. It's like their heaven, right?
Yeah.
Elysium. If you want to get
Elysium.
to Elysium.
Yes. The word came into Latin from the Greek Elysion.
Mhm.
In classical mythology, which probably means Greek mythology,
Mhm.
Elysium, or the Elysian Fields, was the home of the blessed after death, or the home of the blessed after death, the final resting place of the souls of the heroic and the pure. Yeah, I think
Mm,
it's Greek
interesting.
mythology.
So yes, that's Elysium. So Elysium is basically a smaller Tharsis with one main mountain, two smaller mountains, and then a plain to its south. Um, and if Mars were to be filled with water, Elysium could end up just becoming its own island, which would be fascinating. Um, depends on how much water Mars gets, though. But you could end up with Elysium just being this island, this massive island, the only significant island really. It would be like Mars's Australia, right? Elysium could end up being Mars's Australia. So that is an interesting thought. Um, but yeah, so let's take a look at the first feature here, which is Elysium Mons. So Elysium Mons is just another shield volcano, right? Just like the other ones we've looked at. It's a bit shorter, but it's there, right? It's, I don't know, not much more I can say about volcanoes, right? Here I have a picture picture of uh, the main island of Hawaii, right? And if you look at the main island of Hawaii in its elevation, and like if you look at the underwater part, and just imagine if the water was gone, that's basically just Elysium Mons. And so then here on the bottom right, we have a picture of one artist's rendition of Mars with water. And this is Mars with quite a bit of water, I would say. This is like a lot of water. Probably I wouldn't put this much water on Mars. I think this is excessive. But here you can clearly see Elysium becomes its own giant island at the very right, bottom right there. So, so that's interesting. Um, but yeah, it's just another one of these tall mountains. Um, this sort of second place feature. It's interesting. Um, it's surrounded by lower land than the Tharsis, because the Tharsis province just is it's its own thing, right? But Elysium is a bit more solitary. Um, yeah, I don't know. I don't know what this place. This place, it would be interesting as an island, definitely.
Yeah.
So next up, we've got Elysium Planitia. So Elysium Planitia is just the area directly south of Elysium. And here we have two actual landers. So there's the InSight lander on the left and then the Curiosity rover on the right. And so look at this area. It's like kind of rockier and it's interesting. I'm trying to look in the background of this photo. I wonder if that's like Elysium rising in the background, but I'm not sure of the Curiosity photo. Um, it might not be because I think it might be too far away. But it's just interesting to like think of these huge mountains all across the planet. Um, yeah, not much more to say about Elysium. It's just like could end up that's and so Elysium Planitia might or might not end up underwater. That's the big debate here. Is should it end up underwater? And I say no. I say it should not end up underwater. I think that's a bit too much. Like I think Earth's got a bit too much water. You know what I mean? Like
Mm.
70%. Like we really need that much
What do you want to
ocean.
what do you want to knock that
Like
figure down to?
70% of the surface covered in water. Well, I want to leave it as it is because
Mm.
changing it would
Good
completely just
move.
wreck everything. Um, but It should be left as is, because every coastal city would say no. And then also, if you lower the sea level by, say, 1 mile on Earth, right?
Mm-hmm.
Then what happens is all the elevations in terms of air pressure would also essentially shift down by 1 mile. So if you're at sea level, you would suddenly be in Denver in terms of like breathing and stuff.
Mm-hmm.
You know what I mean? So it's not like a change you can make, but it's just on principle, right? Like liking to be efficient, right? It's like, do we really need, 70% of the planet covered in water that we can't use? We can't use this area. I don't know. It's just, since Mars doesn't have much water to begin with, is my guess. It's hard to gauge how much water Mars has because the visible amount of water is not very much, just the ice caps, and it's hard to tell how much is stored as permafrost underground. So it's like, how many aquifers are there? It's like, it's hard to say. Who knows? Who really knows? It's an open question, and so the answer to that question will determine how deep the Martian oceans are. But personally, I think that Elysium, if I had my way, I would leave it as not an island, just because of the other features I want to not be submerged, I guess.
Mm-hmm.
So that would be my preference here. My official here's my official Mars sea level preference is -3 kilometers compared to the datum. So I think the ideal sea level on Mars is -3 kilometers. So the -3 contour. In the book I'm reading, they choose -1, and at -1, Elysium would be an island. So Elysium's an island. But if you had it at -3, Elysium would not be an island. It's basically somewhere between -3 and -2 is where Elysium would become an island. So that is interesting. So this Elysium Planitia, if the Martian sea level stays at about -3 kilometers, right, this whole region would be a huge like flatland area, kind of like Florida, but instead of being a peninsula, it would just like sit between two like higher elevation places. I can't think of an example of that on Earth, so that would be sort of interesting. Yeah.
Yeah.
All right. Next up, we've got the Southern Highlands. So the Southern Highlands are a massive, massive region of Mars. It makes up the majority of the planet's surface. And the thing about the Southern Highlands is that they are heavily cratered. So this goes back to what's known as the Noachian Age. And let me pull up a bit more information about that. So there's a Noachian Age, but then there's also a Noachis Terra, I think it's called, on Mars. And that's basically, the Noachian Age is a period of time on Mars that is from 4,100 to 3,700 million years ago. So 4.1 to 3.7 billion years ago. And these are Martian geologic time scales, which is interesting because we have the Earth's geological time scales. There's like so many of them and they're so in detail. But Mars just has 4. It has the pre-Noachian, the Noachian, the Hesperian, and the Amazonian. These are the time periods in Mars. And then they go into a bit more detail. You got the early Noachian and stuff like that. But it is interesting that in terms of Martian time periods, right, the Amazonian is just 2,000 million years ago to now. Not enough change in all that time to warrant its own time period for Mars. Whereas Earth, if you look at the geological time, it's just interesting, all the names. Like you've got the Holocene, and then you've got what's it called? There's all these names, Jurassic, Triassic, Cretaceous. Those are the best known. But yeah, so Noachian period is when a lot of cratering occurred on Mars. So this is part of, I think it's called the Late Heavy Bombardment. Yeah, the Late Heavy Bombardment. So this is during the solar system's Late Heavy Bombardment, which is like a solar system-wide event. This is the time period where they say that, right, they say, well, this is basically a time period where just everything was being cratered, and it's late heavy bombardment because this is late in the formation of the solar system, only 4 billion years ago, which is pretty late after the solar system had formed. And this is just a ton of asteroids for some reason were destabilized, a lot more than normal. This is like the solar system's finally settling down, but there's still some more issues happening, and everything just gets totally slammed. And it's interesting because the late heavy bombardment ended 3.8 billion years ago, which is also when it's hypothesized that life first formed on Earth. And so it's like nothing would have been living on Earth before the late heavy bombardment ended, because it was just brutal. And you can see that it was brutal when you look at the southern highlands on Mars. So on Earth, all of that scarring has been eroded away, but on Mars, it's still there. It's still there and very prominent. So yeah, so let's look at that. First, we've got the Hellas crater, or the Hellas basin, or Hellas Planitia, goes by many names, but it's Hellas. That's the main thing. And this is where the deepest point on Mars can be found. So that's interesting. And this crater is just some massive asteroid, or really planetesimal, I would say, crashed into Mars at this location and just created this nice elliptical basin, this lower area of land, which is interesting. I mean, this area gets, again, it's the lowest point on Mars, so it gets just as low as the northern lowlands. So it's this little pocket of lowlands within the southern highlands. And so interestingly, nothing has actually landed here, soft landing. The Mars 2, this is like a Russian mission, Soviet era mission. Mars 2 tried to land like on the crater rim of Hellas, but just crashed. So we don't know. We don't have those beautiful ground images like we have from Curiosity and all of our Mars rovers. So it's just unexplored region, the Hellas Planitia. And you can see off to the right, there's a few valleys here. There's Dow Vallis, Niger Vallis, Harmachis Vallis. And these valleys are also, they appear to be outflow channels. That's what they look like too. So at one point, Hellas might have also been a giant sea. It's interesting to think about that. And that's what ought to happen in the future at some point. Have a giant Hellas sea, giant inland sea. Like we don't have that on Earth. You know, the largest inland sea we have is like the Black Sea or the Caspian Sea. This would be like if the Mediterranean Sea was like a few hundred, maybe 1,000 kilometers from the nearest ocean. You know, that's like what the Hellas Sea would be. It's like the Mediterranean, but completely cut off from the rest of the world's oceans. And that is just interesting, like an interesting environment to have. It's fascinating. And it's also interesting to think about the watersheds on Mars, if there would ever be watersheds, because there's something in America called the Intercontinental Divide, which runs north to south roughly through like Colorado. And that's where everything west of the Intercontinental Divide, if a drop of rain falls west of the Intercontinental Divide, it's going to eventually make its way to the Pacific Ocean. And if it falls east of the divide, it's eventually going to make its way to the Atlantic Ocean. There's probably going to be a, inter-Martian divide, right, where you can define some line around the planet where everything within that line is going to drain into the Hellas Sea, and everything outside that line is going to drain into the Northern Sea, or the Northern Ocean. And that's interesting to think about. And so then finally, something sort of interesting here is that Hellas is antipodal to Tharsis, specifically Alba Mons. It's on the exact opposite side of the planet as Alba Mons is. And so some scientists have theorized that, like, and there are some other features like this where craters line up uh, with mountains. For instance, the next crater we'll look at, Argyre, is antipodal to Elysium. And so it's strange to think that the largest crater on the planet is opposite the largest mountain range, and then the second largest crater is opposite the second largest mountain range. Might just be like spurious correlation, but some scientists want to look into, like, it could be a shockwave effect if you think about it, because such a large impact like this, these massive planets of rock sort of just become like more mushy material. And when you get an impact crater like that, the shock waves like reverberate around the planet many times. And so it's conceivable to think that the shock wave through the rock might like crush it together and weaken it enough that magma could upflow through that weakened area. That's sort of the theory, but we cannot know for sure, because that is lots of internal mechanics of Mars.
Yeah.
So next we have Argyre crater, also Argyre based in Argyre, Planitia. It can be all of those things, but this is just another crater, sort of like Hellas, except less intense. Yeah, and something interesting I didn't mention with Hellas, but these craters have nice mountain ranges around them, and these mountain ranges are just from debris that got picked up and dropped in piles around a crater. That's all they are. But they're still interesting because they probably contain materials from the original, like, asteroid that struck and created these craters, and so that gives you some, studying those areas would give you some insight into what's going on. Yeah, and interestingly, this crater hasn't really been visited either. The entire southern hemisphere of Mars hasn't received much visiting from rovers, and I don't know why. It could be like the north is much like smoother. So when you have a rover, it's like a legitimate concern that like it could just like tip over, which would be like one of the saddest things to happen probably, because it's like a turtle. It's like when the turtle flips over, it's like, oh man, like that's just sad. It's like that's what those rovers, they can't be flipped back over. So you want to avoid this area. Also, it's easier, I would say, to land something safely at the lower elevations of Mars, because to land something on Mars, we use both parachutes and rocket fuel, because basically Mars is actually a very difficult planet to land things on, like a very difficult body to land things on. To land something on Earth, just use a parachute, right? You don't need any rockets at all to land something on Earth, right? Because our atmosphere is thick enough. You need a heat shield, right? But you don't need rockets to like slow your descent. You just need parachute, good old-fashioned air resistance, because we have a very thick atmosphere. On the moon, it's just the opposite. There's no atmosphere, and you may think that's oh no, we can't use a parachute. But the moon is so small that it has so little gravity that it's easy to just use rocket boosters. So on the moon, we use rocket boosters because it's smaller. On the Earth, rocket boosters would be ineffective because the Earth is so massive. Mars is like a strange chimera, right? It has this thin atmosphere that's not quite enough to slow your descent by parachute, but at the same time, it has this stronger force of gravity where it's too strong for you to just rely on rocket boosters. So all of the rovers, have been landed with a combination of a parachute and rocket boosters, and it's just interesting. And then it's also that like Mars is, light lag, right? So it's 10 light lagged minutes away, so you can't really land it remote controlled. You have to like have AI do it, which is difficult. And so it's all a mess. But I think my favorite, I must say, my favorite Mars landing solution are those giant like bubble airbag things. Have you ever seen pictures of those, Sebastian?
I have not.
It's really interesting. I think the earlier Mars rovers used that, but let's see. Mars bubble landers. Yes. So this is the Spirit and Opportunity landing. I'm just going to send you the video link here. It's just fascinating to look at this. All right, so first it uses a parachute, right? Then it just enters into a bubble. And then it uses some, I'm not sure if this is bad quality video. Oh, this is bad quality video. So, but it has those bubbles things.
Yeah.
It's like a tetrahedron covered in airbags, and it just bounces on the surface until it comes to a stop. It's so weird looking, but it's hilarious. Like, it's great. Like, that's just, it's so funny. Like it, and of course it makes huge bounces just because it's low gravity. But anyway, that's my favorite solution to landing on Mars. So look up Spirit and Opportunity landing. You'll find something like that. Look up like airbags or something like that. But yeah, that's a very novel solution to the problem. But anyway, so finally, we get to the surrounding Terra, which is pretty much the entire rest of the southern hemisphere.
It's a bad
and so this area, yeah, just incredibly covered in craters, higher elevation. We've got Aeonia Terra, then Noachus Terra, which I mentioned is also the time period, right? So Noachus is named after the time period. Or maybe the time period's named after Noachus. I'm not actually sure on that one. But then you have Sabia, Terrena, Hesperia, Promethei, Cimmeria, and Serenum. And so those are all the areas. So this part of Mars is higher, and it does not get as much water. It's drier. Like, even in the form of ice, it doesn't really get water. But it may have permafrost under its surface. Again, we don't know. But liquid water can't exist at this altitude. So that's something to think about. It's just too high up for liquid water to exist at all on the surface. Although there may be aquifers. That's the big unknown. There might be aquifers on Mars. But yeah, so it's heavily cratered from the solar system's late heavy bombardment, and this surface is older. The northern hemisphere, too, was probably cratered like during the late heavy bombardment, but it's just since been renewed, either by tectonic activity, lava flows, or perhaps just one giant impact crater that wiped out all the other craters. We do not know.
This is where I would build my summer house. Just in the middle of nowhere, away from everyone. Just in the expanse of Mars, I have a little potato farm. I have a bunch of earth flowers that I'm growing in my garden. Small farmhouse in the middle of nowhere. Like,
nice.
maybe even on the edge of a crater. So if we've terraformed it enough that there's like weather cycles, when it snows, I get the best skiing and sledding on the planet. And that's
nice. That actually, that reminds me of a chapter of the aforementioned book Blue Mars, the third in the series. This character Nergal, he goes into the southern highlands and finds like a small unnamed crater, and he basically just makes it like his own little place. Man. He just owns the small crater, and he like plants stuff there, and he has a house that's like, his house is like made out of a hollowed out like boulder, right? So he takes a boulder, hollows it out, makes it into his house, and then he's up there. Sometimes it snows. Eventually I think what happened though was like his crops got like blighted. So a blight. The blight struck his crops, and he ended up having to just like leave. He's just like, oh, my farm was destroyed. So sad. So then he's the same character that ran the circumnavigation Mars run. He's an interesting character. He's born on Mars, so he's like a character in the later books, but like I think he also visits Earth once. He visits Earth once, and it's interesting. He gets the opposite of elevation sickness, right? So he goes down to a coastal area, and it's humid and hot. Whereas on Mars, everything is dry and cold. Even once terraformed, it's drier and colder than Earth, right? And then also the gravity is just hard to handle. But yeah, so he goes to like the lower, like, you know, he goes to the coastline, and eventually he's just like, he is not having it, you know, like he's just like having breathing problems and stuff.
Ooh.
And so then they take him to Switzerland.
Of course.
And so Switzerland is basically just Mars, right?
What a great
if you think about it,
to go
cold
to
and dry.
Yeah.
What a great excuse.
You know,
yeah, they go up to Switzerland.
It's very close to Mars. Cold, dry, no taxes, you know.
Yeah, exactly. So yeah, that's just, it's a good book. You should, everyone read that trilogy. That's a good trilogy. Anyway, so yeah, that's the southern Terra. You can have your own little farm until it gets struck with the blight.
The blight.
It's a tragedy.
But we've hit on both hemispheres, so now there's only two places left.
Yeah, the polar caps. So Mars has two polar caps, and one is mostly made of dry ice, and the other is mostly made of water ice. And so they are both present, and melting them, I would say, would be a good first step in terraforming the planet. So first, you've got the South Polar Cap. This is the dry ice one. And you can look how just like bright and harshly white it is compared to when we look at the North Polar Cap, it's like dingier. Dry ice is a lot like, it's a much cleaner color than water ice, surprisingly. Like you think of water ice as like, yes, this is white material. But dry ice is like even, it's like Vanta black, but it's Vanta white, you know. But anyway, so that's dry ice as seen from space, just a whole lot of it. So 85% dry ice, 15% water ice. So there is some water ice up here. And so this area is called Planum Australe, for southern lands, right? And so interestingly, the poles, right, just like on Earth, the polar caps increase and decrease depending on the time of the year. So in the winter on Mars, or the winter in the southern hemisphere of Mars, which is summer in the northern hemisphere, right? Because that works just like it does on Earth. And so in the winter, carbon dioxide from the atmosphere deposits out of the atmosphere and sticks onto the polar cap and becomes dry ice. And so the atmosphere like slightly decreases in volume, right? But then as spring comes and summer, the ice sublimes off. The dry ice sublimes back into the atmosphere and makes it slightly thicker. So that is just interesting. And it's like quite a sizable shift. It's like 10 to 20%. But there is also a bit of water ice up there. And scientists have just discovered a subglacial lake kilometers underground. So that is really fascinating. So again, at this altitude, water can't exist on the surface, but this is kilometers underground and under the pressure of rock and kilometers of ice above it. So there is a subglacial lake. That's an interesting place, right? They only discovered that through like indirect means, you know, like they haven't sent a probe that can dig kilometers into the Earth, right? But they have just made those observations via orbit, from orbit. And the way you can do that, make an observation like that from orbit, is seeing how your orbit is affected by the gravity of the planet. When we do physics problems, right, we approximate gravity to just be like a point, right? So we're like, okay, you're in orbit around Mars. what speed will you need to go around Mars? And we imagine Mars or Earth or whatever object we're orbiting as if it's just like a point mass. But that, of course, is inaccurate, right? Mars is this blobby, lumpy thing where you've got deep depressions like the Hellas crater and you've got high mountains like Olympus Mons. And so you'll find that there are slight gravitational effects when you go over these features. So if you have a satellite orbiting Mars and it passes over Olympus Mons, the added gravity from the sheer mass of Olympus Mons will actually cause your satellite to slightly speed up as it passes over and then slow down again. Hellas will do the opposite. And that is just fascinating, of course. And so we've had satellites that fly over the south pole of Mars, and they're able to detect the density underground, and they make their estimates. Scientists are very, very resourceful with making indirect observations, especially like space scientists, because there's not a lot of direct observations you can make. But yeah, so if sublimed, this ice cap could about double the Martian atmosphere. That's just according to my estimates here, just based on how much there is. And so that's interesting because that could cause basically a positive feedback loop, a greenhouse effect, where more heat from the sun is trapped in the Martian atmosphere. And so that would help to warm up the planet as well as to thicken its atmosphere, which is something that needs to be done. But at the same time, it would kind of be a problem because it would be putting carbon dioxide in the Martian atmosphere, which is not what we want. We want oxygen. It's a complicated balance. They actually, again, I'm just going to say in the book, right? That's my one reference for Mars stuff. It's my favorite book. So it's my favorite book trilogy. But basically, it's like it's a balancing problem where they want to make the atmosphere hotter and they want to make it thicker, but they don't want it to have a lot of carbon dioxide in it because it would make it hard to breathe. So if you think of partial pressures, right? If you had the Martian atmosphere just as it is right now, and then added in enough oxygen and nitrogen to make it habitable, it would have more carbon dioxide than Earth's atmosphere has in terms of partial pressure. On Earth, the partial pressure of carbon dioxide is 350 parts per million. But on Mars, it would be like 6,000 parts per million. So that's quite a bit. And once you get up to levels of about 1%, carbon dioxide becomes really like poisonous and noxious, and it becomes a health problem. So 0.6% isn't even ideal. So strangely, right, in the process of thickening Mars's atmosphere, we'll actually have to remove some gas from the atmosphere, or at the very least convert it into oxygen somehow and deposit the carbon somewhere, which is a hard task to do. That's not easy. Alternatively, you could just try. So another approach you could try in terms of terraforming Mars is to just go for the carbon dioxide, right? Just say, all right, we'll spike the levels of carbon dioxide and then just let the planet get a lot hotter and then worry about it later. So step 1, increase the carbon dioxide. Step 2, change it and decrease the carbon dioxide, which is might be counterintuitive, but might actually be quicker. Who knows? So that's the south pole of Mars.
And where there's south, there must be north.
Yes. So the North Pole. This is like a tale of two ice caps, right? This is Planum Boreum. This one is visually it's larger. It's made of water ice, which you can see is not as pristine. And that water ice could also be used in terraforming, but there's not really enough of it to refill Mars's oceans. So the Planum Boreum is said to contain 1.2 million cubic kilometers of water. And so above we have my estimate of what that would look like on the poles. I don't think it would complete the ring in terms of the Northern Ocean, but you would get this big, I think that's Utopia Planitia. Here, wait, I'll have to check that. Is that Utopia Planitia? think it might be Arcadia, actually. So, like, Arcadia might fill up with water, that lower elevation area, but that's about it. If you were to just melt the northern ice cap. And so then here's where we get to my estimates, right? I would say Mars probably needs 40 million cubic kilometers of water to get like oceans, a full water cycle, -3 kilometer contour, right? And fill the Hellas Sea too. But then, according again to just my guess, and this is kind of hard to say, I'd guess that Mars only has 15 million cubic kilometers of water stored like underground and stuff today, which is like about half as much as you would need, less than half. And that is a lot of guesswork, though, I will say. It's hard to tell. It might be a lot less and it might be a lot more too. We just don't know. We have to actually get there, make some digs, use like sonar on the ground to like detect if there's aquifers and stuff like that. The whole shebang, right? That's what has to happen. Lots more observation necessary to figure out how much water is actually on Mars. But yeah, that is the world tour. Mars World Tour. There you go. So now
thanks, Max.
you know all the regions.
I think I'm ready to buy. Can you get
ready
me
to buy a quote for the entire planet of Mars?
Yes.
Entire planet of Mars. Let's see. That's a hard one, actually. So the GDP of Earth is $80 trillion.
Yeah.
That's every year. So I would say if you wanna lease Mars for 1 year.
Yeah, I'll lease it for a year.
Then it would probably also be about $80 trillion, maybe less. So maybe you could get like, say let's go with 20 trillion a year. That's your quote. 20 trillion a year. Or wait, no, sorry, quadrillion, right? It's 80 trillion or 80 quadrillion.
It's 80
trillion. No,
yeah,
you're right. 80 trillion. Okay, so 20 trillion.
Wait,
20 trillion is about the US GDP. You don't have it on you? It is the US GDP.
On me, but
you don't have it on you.
Me,
he does have $20 trillion.
I'm good for it.
He's good for the 20 trillion. So yeah, about the US GDP. That's there you go. That's your quote.
But
interesting.
Yeah.
Yeah. That's Mars, right?
Yeah.
Hopefully thoughts. Some of these regions. Oh yeah. Final thoughts. To the viewer, hopefully some of these regions stuck out to you as interesting. Maybe you found a place that you want to build a summer house.
Yes.
On Mars. I think Mars is pretty cool. I like Mars. I don't know. Mars is interesting because I've actually written more about Venus in terms of just my sci-fi stuff, and thought about terraforming Venus because Mars is like so popular that I'm like, okay,
right.
Let's try and like mix it up a bit. Let's try to like say something new. People don't talk about Venus a lot, and Venus, I would say, is underappreciated. There's a lot more potential there than people think. But Mars is also just a lovely planet, I would say. I'd love to go there. It would be fun. It's a lot easier. It's a lot closer to what we have on Earth. It would be a lot harder to set things up at first on Venus, but it might be easier to terraform Venus in the long run. I don't know. It's hard to say. But yeah, I like Mars. The gravity is chill. That's always something. That's nice.
Yeah.
You can, if you drop an object, you have here. I can calculate. I'll calculate how much extra time you have to save your objects from falling. Because it's square root times the acceleration, basically. So 0.38 square root, and then 1 over x. So if you drop something, you have 62% more time to grab it before it falls to the ground and shatters. And it's less likely to shatter because it won't hit the ground with as much speed. and that's just interesting. Just jumping around on Mars would be fun. I was just in my pool yesterday, right? And I was like walking back and forth on the ground in the pool at like various depths of the pool, because basically, since our bodies are mostly water, if you have like, say 75% of your body underwater, that's kind of like simulating gravity on a planet that has 25% gravity, right? You know what I mean?
Mm-hmm.
Like roughly, because you can float on water and be about neutral in buoyancy. And so, anyways, it's just interesting because it's like to simulate those different gravities like that, kind of tricky to do. But yeah, then I watched this video, 30-minute video on the International Space Station, like a tour of the International Space Station, and just the way that things float around. Like most things are clipped to the sides by like, you'll have like you'll have like a something clipped to the side by like a hinge, right? And so they'll like lift something up and it'll either just stay there or just due to its own elasticity, like its own natural like bend, it'll actually fall back in place. And it's just so interesting the way that everything drifts. But then I thought about how like on Earth it's actually the same way. It's just like you do have that constant force of acceleration. I don't know. It's just I've also been like thinking about my physics class that I'm taking now and just seeing force vectors everywhere. You know what I mean? It's like I'm just like trying to imagine everything as force vectors. But I feel like Martian gravity would be quite enjoyable. I think it would be good on the telomeres.
Yes.
Maybe that would make up for the solar radiation that you would be receiving. But yeah, interesting planet.
Yeah, would love to have a summer home there. Would love to have my little crater to myself and grow my crops that would hopefully not succumb to
Hopefully
blight.
not get yeah. I want to send you this chapter now.
Yeah.
Um, but yeah, so yeah, I guess that's about it. So thank you everyone for watching, and thank you Sebastian for being my co-host as always.
As always.
We will see you guys next week. Hope you enjoy your 3-day weekend, everyone. All right. Bye bye.
Bye bye.